Welcome students, let us see a very interesting law from algebra of sets. So here law is known as Demorgan's laws. Demorgan's laws. The first law is A union B whole complement is A complement intersection B complement. And second law is A intersection B whole complement is A complement union B complement. We have to see these two laws very carefully. You see here operation union is here in left hand side, which is becoming intersection in right hand side. And conversely, in second law, here operation is intersection and right hand side it is becoming union. So here first law is the complement of union of two sets is equal to intersection of their complements. And in second law, this is complement of intersection of two sets is union of their complements. It's the proof of these laws is very interesting. So let us see proof of first law. A union B whole complement is equal to A complement intersection B complement. Here we will use some properties of set theory. The first property which we will use is if X belonging to any set A implies that X belonging to another set B, then it means A is a subset of set B. We need to understand it. A is a subset of B means all elements of set A are available in set B. The same statement is here also. If X is any element in set A and if implies that this element X is belonging to the set B, then it means A is a subset of set B. This property we will use here. And another property which we will use, that if A is a subset of B and B is a subset of A, then set A is equal to set B. If set A is subset of set B and again B is subset of set A, this is possible only when these two sets A and B are equal. So for proving of this first law and second law of Demorgan's laws, we will use these properties of set theory here. So let us start the proof. First of all, we will apply this property. Here we will show that X is any arbitrary element belonging to LHS, and we will show that this implies that that element X belongs to RHS. By this condition, LHS will be subset of RHS. Similarly, in the second step, we will show that RHS is a subset of LHS. And by combining these two results, we can prove that A union B whole complement is equal to A complement intersection B complement. Means we can prove that LHS is equal to RHS by using this property. If LHS is a subset of RHS and RHS is a subset of LHS, then LHS is equal to RHS. Okay. So let us start. Let X be any arbitrary element belonging to set left hand side A union B whole complement. Okay. And you know what is complement? Complement means if X belonging to A complement, this implies that X will not belonging to set A. Because by definition, A complement is universal set minus set A. You know, universal set is the biggest set under consideration and A is a subset of universal set. So A complement we can obtain by subtracting set A itself from universal set. So since set A is being subtracted from universal set, element belonging to A complement will not belong to here RHS. Okay. So you see, we are assuming that X is any arbitrary element belonging to this left hand side, A union B whole complement. What does it imply? It implies that X does not belong to A union B, because if any element is present in complement of a set, it means X will not be present in that particular set. Okay, and this implies that if X is not present in A union B, it means X is neither present in A or X is not present in B. Means X is not present in both the sets A and B. So it implies that X is not present in A and X is not present in B. So this implies that X is belonging to set A complement. If X is not in A, it will be in A complement. Similarly, X belongs to B complement. If X is belonging to both the sets A complement and B complement, it shows that X is belonging to intersection of these two elements, because X is common in both the sets. So X belongs to A complement intersection B complement. Now you see, here we had started from left hand side, X belonging to left hand side, and we are coming to X belonging to right hand side. What does it mean? It means that LHS is a subset of RHS. Therefore, A union B whole complement is a subset of A complement intersection B complement. Let us call it relation number 1. Correct. Now let us use the reverse path. We will start from here. Next, let X is belonging to right hand side, A complement intersection B complement, and we will try to show that X belonging to right hand side, X also belongs to left hand side. The right hand side will be subset of left hand side. So this implies that intersection is here, so X will belong to both the sets. So X belongs to A complement and X belongs to B complement. Now if X is belonging to A complement, obviously X will not belong to set A. So this implies that X does not belong to set A and X does not belong to set B. Correct? If X is not belonging in both the sets A and B, it means X will not belong to union of these two sets A and B. So this implies that X does not belong to union of these two sets, and this implies that X belongs to A union B whole complement. So you see, here we had started with right hand side, X arbitrary element belonging to right hand side, and we are coming here, X is belonging to left hand side. So what does it show? It shows that RHS is a subset of LHS. So this shows that A complement intersection B complement is a subset of A union B whole complement. This is relation number 2. Now we will use this property. If A is a subset of B and B is a subset of A, then A is equal to B. So by combining these two results, here we find LHS is a subset of RHS, here RHS is a subset of LHS. So by combining these two results, LHS will be equal to RHS. So therefore, by combining relation number 1 and 2, we can conclude here that A union B whole complement is equal to A complement intersection B complement. So first law of Demorgan has been established here, has been proved here. So this is very simple. Now accordingly, we can do this second question also. So let us see the proof of second law of Demorgan. Let us see the proof of this second law. A intersection B whole complement is A complement union B complement. Here also we'll start from left hand side. So we'll start from here. Let X be any arbitrary element belonging to left hand side, A intersection B complement. This implies that if X is belonging to complement, X will not belong to this set. X does not belong to A intersection B. If X is not belonging to intersection of these two sets, means X is neither belonging to A or X is not belonging to set B. So this implies that X does not belong to set A or X does not belong to set B. And what does it imply? If X is not belonging to A, X will belong to A complement. So X belongs to A complement or X belongs to B complement. X belongs to B complement. Correct? And OR is here. So in place of OR, you will write union. So this implies that X belongs to A complement union B complement. So you see, here we had started from left hand side, X is belonging to left hand side, and we are coming here right hand side, X belonging to right hand side. So therefore LHS is a subset of RHS. Therefore A intersection B whole complement is a subset of A complement union B complement. Suppose this is relation number 1. Now we'll follow the reverse path. Let X belongs to right hand side. X belongs to right hand side. A complement union B complement. This implies that union is here. So X must be either in A complement or in B complement. Then only X will come in union of these two sets. So this implies that X belongs to A complement or X belongs to B complement. And this implies that if X is belonging to A complement, X will not belong to set A. X does not belong to set A or X does not belong to set B. See, X is not belonging to A or X is not belonging to B. It means X is not belonging to both the sets A and B simultaneously. So X will not belong to intersection of these two sets, because so here X does not belong to set A or X does not belong to set B. It means X is neither in A nor in B. So X will not belong to intersection of these two sets, because for intersection of sets X must be belong to both the sets. But here obviously X is neither belonging to set A or X is not belonging to set B. So it shows that X does not belong to A intersection B. I hope you have understood it, because here X is not belonging to A or X is not belonging to B. So X will not belong to A intersection B, because X will belong to A intersection B only when X belongs to in both the sets A and B. So this implies that if X is not belonging to this set, X will belong to its complement. So you see, here we had started from right hand side, X element of right hand side, and here we are coming, X is an element of left hand side. So by this property, X belonging to A implies X belonging to B means A is a subset of B. So therefore here LHS is a subset of RHS. So therefore A complement union B complement is a subset of A intersection B whole complement. Relation number 2. In relation number 1, LHS is a subset of RHS. And relation number 2, RHS is a subset of LHS. So by using this property, if A is a subset of B and B is a subset of A, then A is equal to B. So here LHS is a subset of RHS and RHS is a subset of LHS. So by combining these two relations, LHS is equal to RHS. So therefore, by combining relations 1 and 2, we will get LHS is equal to RHS. A intersection B whole complement is A complement union B complement. So this second law of Demorgan is also being proved here. So proof of Demorgan's law is very interesting, very simple, little bit logic, but you can do it very easily. So students, I hope you might have subscribed to my channel. If you have not subscribed, please do it immediately and keep watching my videos and enjoy learning mathematics. Thank you very much.